Let's review and also go into a little bit more depth on the difference between atoms forming just elements and atoms and compounds. And then we'll talk a little bit about how to represent compounds. So remember, our atoms are all going to have a really small nucleus surrounded by electrons, right? So E minus for electrons and protons and neutrons, P and N. Right. So that's our atom. So we're going to see these kind of organize themselves in two ways. One, elements, which we kind of have a couple options. We'll either see atoms kind of form a solid and arrange themselves nicely next to one another. And they'll exist kind of in space close and in an organized fashion. And they'll all be the same element right next to each other. So we could think about these as all being let's say all sodium atoms. So it could be something like that. So metals are typically going to just arrange themselves next to each other in those solids. Or we're going to see like our nonmetals, we saw that as elements, they sometimes actually formed compounds. And so what that really means, kind of in a simplified version, is that there's a couple versions of it, which we'll talk about over in compounds. But when we're thinking about elements, we're taking two atoms that are the same element, and they're going to share electrons to kind of follow that octet rule, right? So that way each nucleus thinks it has 8. And really, I like to think of it, and I'll make this a little bit bigger, as the electron cloud. So we've got our little nucleuses here, right? But the space that the electrons can occupy overlap, kind of like a Venn diagram, right? And so those electrons that were once just attracted to, so this electron here is like attracted to this nucleus. Now an electron could be attracted to both of these nucleuses. And that would be a covalent bond. That is like forming a molecule. And so our elements can exist in kind of both of these ways. But the thing, so an example of this one would be something like oxygen, like O2, right? There's not, that's a possible one. But in this case, it's only O2 atoms in this example, or only sodium atoms. There's no other type of element incorporated into the substance. And so our elements kind of come in these two options. And then we have compounds. And the difference with compounds is that it is going to be more than one type of element. And so because of that, we are still going to kind of see two different types. But the trick is it's always at least two. It can be a lot more. Let's look at ionic compounds first and then covalent molecules. So all compounds, it's like an umbrella term, can either be a covalent molecule or an ionic compound. We call it covalent or ionic compound. So ionic compounds form between ions. So it'll form between a positive ion and a negative ion. So remember, that's called a cation and an anion. So these are elements or atoms that are an element that have an imbalance in their electrons and their protons. And so that makes them no longer in their elemental form. They are an ion and they have a charge. So remember, opposites attract. So we always need something that is going to be negative and something that's going to be positive. An example of this might be chlorine and like a chlorine and a sodium plus next to each other. And now it's usually not just two atoms next to each other, but instead it's looks a lot more like the solid, where it's going to be lots and lots of these. And they're going to alternate. They're going to arrange themselves so that way each ion is surrounded by ions of the opposite charge. So a positive cation is surrounded by anions that are negative. And each anion is surrounded by positive cations. So this is one type of compound, an ionic compound. And these ones really are just like attracted to each other like magnets because they're opposites. And that type of attraction we call ionic bonding. And this typically happens usually between a metal and a non-metal. Not always, like there's exceptions to everything, right? But remember our chlorine here, this is our non-metal, and sodium is a metal. Even though it's an ion instead of a element, it still has the like it's still either a metal or a non-metal or a metalloid. So these are typically this. So then in our covalent molecules, like we were talking about here with our oxygen, we're going to see those atoms electron kind of clouds overlap. I'm going to do one that's, and it can be more than two. So like here's one that would have three things overlapping. This example I'm going to do is CO2, where we have oops, a carbon atom and two oxygen atoms that are overlapping with one another. And they do this to kind of share electrons. And so it kind of tricks the structure into thinking it has 8 electrons around it instead of for carbon 4 and for oxygen 6. And this really represents then a covalent bond. And so when we are looking at a chemical formula, we're going to, or a name of something or a description, we're really going to be trying to like place it as in its category. Like as I'm learning about something, like, is this just an element that I'm reading about, something that's just one type of atom repeated, or am I looking at a compound that's a mixture of atoms that are going to then kind of give it a different character than just the individual atom or element would? Sorry.